Hello everyone. In this lecture we have an objective which is how to determine the Ix, the moment of inertia about the x-axis for the right angle triangle by using horizontal strip parallel to the external x-axis. We have here right angle triangle in two shapes. The first shape that we have the triangle AB, adjacent side at the base and the opposite side at the left hand side of the triangle, and this is the hypotenuse side. We are going to make the x-axis coincide with the adjacent side and the y-axis will coincide with the opposite side. We are going to use horizontal strip parallel to the x-axis at the adjacent base, and the same result we can obtain by using vertical strip, which is perpendicular to the external x-axis. This is the angle ABC, and we have a horizontal strip with width x equal to x and height equal to dy. This horizontal strip is apart from the x-axis by distance equal to y, and here is our x coincide with the base and our y-axis coincide with the left edge of the triangle. First, we are going to establish a relation between x and y. For the equation of the line BC, we have y equal to minus h over bx plus h. We want to check that equation is okay or not. We are going to substitute by the coordinate of point B. If you put x equal to b, you're supposed to get y equal to 0. So y equal to minus h over b. When we put x equal to b, then b goes with b. We have minus h plus h, which is 0. This will satisfy the coordinate of point B. While for point C, if we put x equal to 0, then this term will go to 0. We left with y equal to h, which is exactly the y coordinate of point C. Since our strip is horizontal and we are moving from y equal to 0 to y equal to h, we are going to substitute. We are considering the area dA equal to x multiplied by dy. We are going to find a value of term of x as follows. We have y equal to minus h over b multiplied by x plus h, which you have already checked. We are going to rearrange that equation by considering y minus h equal to minus h over b multiplied by x. Then we find a value for x that will be minus b multiplied by y minus h divided by h. We are going to substitute back for the equation of the dA, which is the area of the strip, equal to x plus multiplied by dy, equal to our x is minus b. Instead of writing the minus, we can rearrange and write that it is b multiplied by h minus y divided by h. Again, we have to multiply by dy. Our moment of inertia in the x direction for that strip equal to dA multiplied by y square, while for the complete right angle triangle we have to integrate, so our capital Ix equal to the integration of the multiplication of dA by y square from y equal to 0 to y equal to h of the following: b over h multiplied by h minus y, again multiplied by y square dy. Our common, we can get out b over h as constant outside the integration. Then again our Ix equal to b over h, the integration from 0 to h of h y squared dy minus y cubed dy. Again, we can perform the integration. The integration of y squared dy is y cubed over 3, while the integration of minus y cubed dy is equal to minus y to the power of 4 divided by 4 inside brackets. And we are going to substitute from y equal to 0 to y equal to h. So again, ix equal to b over h. We open one bracket. Inside we have h over 3 multiplied by h cubed. Then we have h to the power of 4 minus 1 over 4 multiplied by h to the 4. We make the denominator as 1 over 12. This becoming 12. So we have the ix equal to b over h multiplied by h to the 4 over 12. At the end, our moment of inertia will be bh cubed divided by 12. The expression we have obtained by using horizontal strip. Next, we are going to have the same result, but this time using vertical strip. We move to the same triangle, but this time we have vertical strip apart from the y-axis by distance equal to h. This strip, the height of the strip will be equal to y, and the width of the strip will be equal to dx. And the same equation holds good, y equal to minus h over bx plus h. Since we are moving that strip from x equal to 0 to x equal to b, then again we have to cancel the y from the equation of dix as follows. Dix equal to dx. As we are going to see, our strip is same triangular shape, and we have evaluated the moment of inertia of triangle at the base being equal to the parallel, which is dx multiplied by the perpendicular cubed divided by 3. So we are going to use this fact as our strip moment of inertia for single strip equal to dx multiplied by y cubed over 3. Directly, we can use the expression of y equal to minus h over b x plus h raised to the power of 3 divided by 3 multiplied by dx. Here, the expression will contain only x, which will be okay. So y cubed equal to minus h x over b plus h multiplied by the square of it, which is h squared x squared over b squared minus 2 h squared x over b plus h squared. Again, multiplying the two brackets, we have y cubed equal to minus h cubed x cubed over b cubed plus 2h cubed x squared over b squared minus h cubed x over b, and this is the second term, which is h cubed x squared divided by b squared minus 2 h cubed x over b, and the last term is h cubed. We are going to check the common items. We find that highlighted by yellow, we have 2h cubed x squared over b squared. We add 2h cubed x squared over b squared, and also we have minus h cubed multiplied by x divided by b, and again minus 2h cubed x over b. At the end, we have y cubed equal to minus h cubed x cubed over b cubed plus 3 h cubed x squared divided by b squared minus 3 h cubed x over b plus h cubed. Back again to our equation gix equal to y cubed divided by 3 multiplied by dx. So we are going to divide the previous expression by 3, and then we'll multiply by dx all. So we have our expression gix equal to 1/3 multiplied by minus h cubed x cubed over b cubed multiplied by dx plus 3 over b squared h cubed x squared dx. minus 3 over b h cubed x dx plus h cubed dx. We are going to make the integration. So the integration of dix, integration of x cubed dx is x to the 4 over 4, while the integration of x squared dx is x cubed over 3, and the integration of x dx is x squared over 2, while the last term, the integration of dx, equal to x. We are going to get 1 over b as a common constant, and we are going to substitute from y equal to 0 to y equal to, from x equal to 0 to x equal to b. So we have the first term minus h cubed over b over this b cubed. We get b out, so we left with b squared. And here we have x to the 4 over 4. We substitute, plus 3 over b h cubed over 3 multiplied by x cubed, minus 3 over 2 h cubed x squared from 0 to b, plus h cubed x. But this time we are going to multiply it by b to compensate for the other b. After substitution, we have this term, the integration of dix equal to 1 over 3b multiplied by minus h cubed b to the 4 divided by 4b squared plus h cubed b cubed divided by b, because the 3 will go with the other 3, minus 3 over 2 h cubed b squared plus h cubed multiplied by b, again multiplied by b. We are making rearrangement of the term. Here, for the first term, we have h minus h cubed multiplied by b squared divided by 4 plus h cubed multiplied by b squared minus 3 over 2 h cubed b squared plus h cubed b squared. So our ix equal to 1 over 3b. Our denominator is 24. So we have here minus 6 plus 24 minus 36 plus 24, all multiplied by h cubed b squared. We will add, we have 24 plus 24, 48, minus 36. We have minus 48 minus 36, we have plus 12, minus 6, we have plus 6, 6 over 24 over 3 again. So our expression we can rewrite as 6 over 3b multiplied by 1 divided by 24 multiplied by h cubed b squared, which is 1 over 12b h cubed, which is the same result as we have obtained from the previous horizontal strip. At the end, our k square x, which is the radius of gyration expression, k square x equal to ix divided by a, and our ix is bh cubed divided by 12. We are going to divide by the area, which is 1/2 bh. We left with h squared over 6. Taking the square root of that term will give us kx, the radius of the gyration in the x direction, equal to h over the square root of 6. This time we are going to get an expression for the moment of inertia about the CG. We are going to draw inside our previous triangle ABC two axes, x dash and y dash, in order to get the moment of inertia at the CG. The x dash is vertical distance from the x-axis is h over 3. Our previous expression for ix equal to bh cubed over 12. In order to get the ix CG by using parallel axis theory, that ix CG equal to the moment of inertia at external axis x minus the area of the triangle multiplied by the y square which is the square of the distance, vertical distance from the CG to that X. Our area is 1/2 BH, and our Y bar, this we call it Y bar, equal to H over 3. To our IXG, the moment of inertia, X at the CG, equal to BH cubed over 12 minus the area, multiplication of the area, which is 1/2 BH, multiplied by the square of Y bar, which is H squared over 9. Our common term is BH cubed. We open one bracket, 1 over 12 minus 1 over 18. So we have BH cubed. If we make the denominator as 18, in the numerator we have 1.5 minus 1, again equal to BH cubed divided by 36. Our radius of gyration will be K squared X at the CG equal to IG over the area. Our IX is BH cubed divided by 36. Again, we will divide by the area, which is 1/2 BH. So the square of K X at G is H squared over 18, taking the square root in order to get the radius of gyration KXG. We have the square root of H squared is H. The square root of 18 is 3 multiplied by the square root of 2. Thanks a lot, and see you in the next new topic. Goodbye.